Hi, everyone. I'm Sula Sidigu, data scientist based in the San Francisco Bay Area. I began my data science journey shortly before the pandemic, and I'm excited to presenting again to you all today. Let me go ahead and share my screen. Okay, so today I'm going to be speaking about updating and deleting data and also creating and manipulating tables. So just some few considerations to keep in mind is that these changes we're talking about are irreversible. So it's best to make a copy at least before going through with it of tables and schema. And also the ability to do so might require extra security privileges. And then if you have a table that has a foreign key connected to another table, it may not be possible to do the change just because whatever you're changing could affect that other table also. So to begin with, updating and deleting. Update refers to changing existing rows, whereas deleting means removing the rows themselves.
And Sule, if I could jump in real quick, the author doesn't actually talk about foreign keys until like the last chapter of the book or something like that. So we haven't formally talked about them, but in relational databases, you often have multiple tables. And so we've talked about this idea that like you might have an order table, and inside of your orders, you might have a customer ID, and that refers to a particular row in the customers table. So the way most relational databases are set up, the way most people set them up, is they will actually create an explicit linkage, which is where the term foreign key comes from, between the orders table and the customers table. And if you try to delete a row in the customers table when there are orders in the order table with that particular customer ID, that would cause a problem, because then those orders would be linking towards a non-existent row. And so that's what Sule meant when she said you might get an error message if you try and remove something, if in fact, you know, things are linked. All right. And if you don't understand that fully, we're going to cover it more, but I just wanted to kind of give like the quick cliff note.
We'll understand it after we go through it later on.
Yeah.
So as far as updating, this is the format for it. Use the update clause in the table name, set, and you specify what you want to set your column to. If it's just one column, it would be just this line. And if it's more than one column, then, you know, comma, the next column, etc. And it's important to have a where condition because you don't want your update to affect other things. So this is just a fun example I made up. If we had the CEOs table and we want to set the CEO to Elon Musk, if we don't have this last line here, it would just set for every CEO as Elon Musk. So yeah. And a fun way to think of it is that, well, sorry, some other considerations is that you can include the select statement. You can use that with your updates as well. Some databases allow updating values to a table using values from another table. So you can refer to another table, but that depends on your database. So not all of them allow that. Null and the empty string are two different things. So just keep that in mind as you're going through this. And this isn't mentioned in our book specifically, but I found that there is a case where you can make a change, then see the change before actually permanently committing to it. And this specific example is based off of PostgreSQL syntax. So I know it might be a little bit different for your database management system. So in this case, if you use start transaction and then set the update that you want, then you can, for example, say, select whatever the table that you updated, then you can see the change that it would make. If you decide you don't want that change, then you would say rollback, and then the change it would be like it never happened. But if you want to keep the change, then you'd say commit, and that change would now be permanent. I was just curious if anyone else who's used SQL has actually used transactions before, because I have not.
Yeah, I've used transactions, and I've definitely used it in exactly this way. So I'm about to update something, and I'm a little bit worried, and so you say start transaction. There's another syntax you can actually name the transaction. Okay, so I would say like start transaction T1, and then I run my update, and then this is the important thing. So like if I'm using a particular tool to connect to my database, you have to do it in the same connection. So the same window, the same connection, whatever. And then you can run selects and see how everything looks after the update, the delete, the whatever has run. And if you're happy with it, then again, in that same connection, then you would issue either the rollback transaction command or the commit transaction. And so again, if you named it, you could say commit transaction T1, just to be a little bit, more precise. So definitely what you said, that's a way to preview the changes. And the connection business is important because actually for everyone else, they either aren't going to see your changes, or they're going to, typically, they're just going to be blocked, and all of their queries are going to fail until you either roll back or commit. So you don't typically do something like this where you're just like sitting around drinking your coffee trying to decide if you like your changes or not. You wouldn't typically do that on a production system, because then people would be locked out from seeing things, because it doesn't know whether show the before or the after version to them. Yeah. Okay. Where this gets used in production systems, this is not like you're previewing things. The classic example is you transfer $100 from bank account A to bank account B. So then what it would do is it would say start transaction, begin transaction, and it would issue the update to account A to say subtract $100. And then it would issue the update to account B to say add $100. And then there would be a commit. And so either both of them will succeed by the commit, or if anything goes wrong, then the whole thing's going to be undone as though nothing happened. But you'll never wind up in the state where the first account lost $100, but the second account never got the 100. So that's the main purpose for transactions. And I think they are covered later in the book also. Again, these are not critical concepts typically for your average data scientist, but maybe just to be aware that such a thing exists.
Yeah, I tried doing it in the live Oracle SQL, but it wouldn't let me. Maybe I don't have, the security privilege to try that out.
Did you get a particular error message, or?
Yeah, I did. I don't remember what it was exactly, but I tried this exact what is it? This exact format.
Okay.
I tried Googling something, but
yeah. So I can't remember. I think the syntax might be begin transaction instead of start transaction. But then you would only run the part up through where, right? And then you can run selects to look at things. And then in that same window, then you would run either the rollback or the commit. Okay. So I would think it should work. I don't think you need any special permissions, but it might be the syntax.
Okay, maybe I'll try it again another time.
Yeah. The thing is a little bit confusing. It's just you're showing the code, but you don't run all of it at once. You run like little bits at a time. And so it's hard to kind of show that in time business.
Yeah. Right. So actually, maybe before I get to delete, any questions on what we've covered so far? All right.
Cool.
So
yeah. So you can update one row at a time, or you can update multiple rows. That both are possible.
So delete has a similar format to select, delete, and then you tell it which table name you're deleting from. And of course, you need your where clause so that it doesn't delete from the whole table. And from is optional, but for some databases, but it's good to include it for cross-functional just so you can use it in your query in multiple databases. Delete deletes the rows, as I mentioned before. But if you, let's say you want to delete the whole table, you would actually use drop table, not just delete. And a faster way for deleting rows is to use this truncate statement instead. And transactions also works with delete.
Yeah, you may need special permissions to do deletes. You also may need special permissions to do truncate table, just so you know. So it might not allow you to do it. You might have to actually just delete all the rows.
Okay, so that was the first section. Any questions on that? All right, so the next section is on creating and manipulating tables. And also the same conditions apply as before. Be cautious, may need extra privileges, and again, formats can vary. So when creating a table, we use this create table clause, and then we specify the table name. And then for each column, we want to pass on information about the column. Like, for example, the name, the data type specifically, and whether it's null or not null. Some databases, you don't have to specify this because it assumes it's null by default. But again, for cross-functional use, you should specify. And these are just some of the data types that are available. And keep in mind that the naming might vary between different DBMSs. For example, I found that the date time data type is called timestamp in Oracle SQL. Okay, let's talk about manipulating tables with default values. So when you create your table, you can give it a default value. You just use the default clause and you say whatever it is you want for default. And I found that this may vary for your database, but in Oracle SQL specifically, when you're specifying the default value, you actually don't need to say, not null or null, because it'll assume whatever you have as default. And there's several different data types exist. For example, this integer, etc. The current date default function, what you're naming it, can vary by DBMS. I think some of these are listed in our book. If it's not, just check the documentation for your DBMS. Now for altering table, let's say you can do different things, like you can add or drop the column, rename it, you can modify it. For example, let's say you want to change it from one data type to another, then you would modify the column. And these are just two examples. For PostgreSQL, they use the alter column instead of modify column. So it's just a little bit different. Any questions on this so far?
Yeah, so if I can add a little color, I don't think manipulating tables is very common, but creating tables is something that you may find yourself doing, because if you have a really complex set of things that you need to do, you might want a temporary place to store some intermediate data, right? And so you might create a table that holds some, big queries worth of information that's an intermediate value that you then further use that in order to query more and more. And so that's a relatively common practice if you're just doing some, I don't know, you know what I mean? Like if you're finding all the orders that meet this criteria, and you're finding all the people that meet that criteria, and you're finding all the products that meet that criteria, and then finally you want the combination of those three, you might just create like 3 tables to hold those intermediate super complex queries, because one ginormous query that's like 3 pages long might not work so great.
It's something you do fairly often, you'd say?
I do, and especially if I'm doing something that's, again, not production, then I'm not as worried about performance. And so sometimes it's easier to just kind of do smaller pieces and put them together, even though technically you might be able to write one big query with a lot of joins that just kind of does it in one, big thing. But at least for me, I find, smaller pieces, and then you can also inspect them. You can see how many rows did I get and what do they look like. And oftentimes that ends up just being simpler than trying to do it in one big shot. Also, what I said at the very first session, that there is no sense of ordering or time when you run a query. It's just sets. And so if you want to do, I don't know if I can think of an example, but sometimes if you want to do this and then you want to do that, if you manually create a table that has the this and then you do something to turn it into that, you can force that to be a sequential kind of a step. Whereas, again, when you write a query, everything is parallel, everything is just set operations, and so there's not really like a this and a that kind of there's no temporal, sense of things.
So tying into that, the general process for creating a new table from a table that already exists is you would create the table and include the data types, how many characters, etc. And then from that, you can insert the data into a new table from the old table. This goes over things we had covered a couple of sessions ago, but you can use insert into and you're going to select from your old table and put it in. And then, of course, use select to make sure your table looks correct. And then after that step is when you can rename, or if you so choose, delete the old table, and then give the new table the old table name. And if there's additional steps, other things you want to add, you would do that then. And as I mentioned before, if you want to completely delete a table, not just the rows in it, you can say drop table and then give the table name. Any questions? Right, I can't see the chat, so. Thanks, everyone.
All right. Thanks, Sule. Anybody else have any comments or questions about either the update stuff or the creating, modifying table stuff?
Yeah, could we go over that rollback feature one more time? Like how to, so it from what I understand, it doesn't actually create anything. So you don't have to undo it. So is it just a way of checking your work before anything permanent gets happens?
Yeah, so we actually, I haven't read ahead, so I don't know how well the author goes into details, but we will cover transactions in lesson 20. So it's coming up in a week or two. But the idea is that a transaction is meant to be atomic. So either everything inside the transaction happens or nothing inside the transaction happens. And so I was giving an example of like the bank transfer. You really want the plus 100 and the minus 100 to either both happen or neither happen, okay? But it just so happens that since databases have this capability, most relational databases have it, you can use this to your advantage, where if you write an update or a delete that's inside of a transaction, if you don't finish the transaction, you can peek and see what do the results look like, but you can explicitly manually cancel that entire transaction using the rollback command. So if I said, I want to, I'll use Ian's example from the chat. I want to delete Elon Musk as the CEO, okay? And I say, I'm going to, actually, I don't know if technically he's the CEO of Twitter, maybe it's just the owner. But anyway, so if I just said, I'm going to delete my Elon Musk, okay? And then I'm thinking that it's going to delete him from Twitter, but then all of a sudden it says Elon Musk has been deleted from 4 rows because he's the CEO of other companies too. That was not what I meant to do. Then I'm like, oh no. Well, if I didn't have a transaction, it would just be done. It would be all 4 rows would be gone. Okay. If I said begin transaction, my delete statement, and it says I've deleted 4 rows for you, Ted, then I'd be like, oh crap. Then I can just say rollback transaction, and it'll be as if I never issued the delete command.
So it's a separate statement?
Yes.
Okay.
And so again, in production code, you're not usually doing it so manually. You just have this section of code that's basically sort of like, SQL's very old, so it doesn't have like advanced error processing things like try, catch, whatever. But basically you have your begin transaction, you have a bunch of SQL, and then you have the commit transaction. And if any error happens, then the whole thing just bombs and it'll never get to the commit. Okay, it's very rare that you explicitly roll back. It's usually just like a manual kind of a thing. If it had better error handling, then you might actually say like, if this happened, then commit, else, roll back. You might occasionally see it. But again, we're trying to really focus here on the things you're most likely to do is just write selects to pull data out of some giant database so that you can do your machine learning thing. And so it's good to know that these things exist, but I don't expect anyone to, expect you to be an expert on this. But if you like databases, then you can keep learning more, and that's a whole nother career option, being a database guy. Does that answer your question, Harold?
Yeah, that was perfect. Thanks.
All right, awesome. Any other questions?
And we're gonna, I guess, get to more of that later on in the book.
Yeah, I mean, the book does cover things fairly lightly, but that's one of the reasons why in the sessions we just have like a little color in case people are wondering, well, why would I use it, or when would I use it, or something like that.
So it's like a undo for Excel.
It is. Like I said, I don't think it was created for the purpose of giving you the ability to do undo. But in effect, it does have that. The problem is that the whole time when you're thinking about whether or not you're undoing it or not, nobody else can look at the data that you've worked on.
Right.
They're just going to be getting a blinking cursor and a blank screen. So it's not the world's greatest option for production systems.
I have a question. When we got a query, when we do all these processes, where is our data? It is in the memory, and it fits in the memory. Just
so which part are you talking about? Are you talking about like the data that gets returned to your screen, or what?
Yes, the data which comes back in my screen.
Yes. So when you run a select statement and the data comes back to you, the database server has sent it, and then if you're using a special tool, or like I showed, like a Jupyter notebook where you can run queries, then basically, you know, a full copy of that information has to be transmitted to you. And in the case of my Jupyter notebook, it then goes to Python, it goes to Jupyter, and it displays it on my screen. The database, as far as it's concerned, it's long gone. It sent you a copy of whatever you wrote in your select, and it doesn't know if you're keeping a copy of it or what you're doing with it. Its sole job is just what's being stored in that database on those special database disks.
But it could be huge.
Yeah, if you have a table with 100 million rows and you say select star, your screen's going to be scrolling and your connection's going to be tied up forever. You know, it'll take a super long time. So I actually had this problem, this particular data set. It was like, I think 200 million rows or something like that. But I actually really wanted to load it into R and do some analysis on it. And so like, I basically had to run the select statement and then just go get coffee. And it like took hours for it to like copy it to my C drive, my local disk.
What was the system?
So at work, we have Microsoft SQL Server, and
Okay.
and there's a special Microsoft tool for running queries, and it does have an option to say, save the output to your screen or save the output to your disk. And so I could, you know, give it a file name, but it still took hours for it to copy all that stuff over. All right, any other questions? Okay, so I'm going to now circle back to last week. We talked about this particular coding problem. You have two tables, one that has employees with their salaries, and then just a department table. So you can use the department ID to look up the full name of the department. And the simple question you can ask is, for each department, what is the highest salary that you see in the database? Okay, and you can have a query. I don't know if my screen's a little bit small. You can have a query like on the right-hand side of my screen, something like this. I should probably also add an order by. It's always best practice. All right, so I can select department ID and use the aggregate function max to say the max salary and add my employee in my department. And so this is, I would consider this to be, you know, in terms of like easy, medium, hard, I would consider this to be a fairly easy query. Okay, where this gets harder is if I want to know the, oh, and then I could also include the department name here. That wouldn't really change how difficult it is. I could say D dot, what is it? Department dot name. But then I just need to change my group by to say I'm also grouping by name. Okay, so this would give me the two columns for the department and what's the max salary for each department. So the harder part is, what if I asked you to show me the name of the employee that had the highest salary? So max will give you the max value in this column, but it won't tell you what row it came from, and max won't let you access any of the other columns in that same row that it found the maximum salary. So using just the things that we've talked about, it is possible. There's many ways you can solve this problem, but using just the stuff we've talked about, it is possible to also get the employee name. So has anybody had a chance to, and I also posted this in the book club channel on our Slack. Anybody had a chance to think about this problem over the last week?
Yeah, I took a stab at it, but before I get into that, so the department ID that you're joining on, you're assuming that that's going to have the same ID as just the regular ID?
So I think they say here, so in the department table, each row of this table indicates the ID of the department. Okay. And department ID is the ID from the department table.
Okay.
Okay. And it's using this term foreign key, which we haven't actually explained yet. But basically what they're saying is that in the employee table, this column, if it says 5, then there must be a row in the department table with ID 5.
Oh, okay.
And that's
Okay.
why we join on these two things being equal.
Oh, okay, got it. Yeah, I did my join differently, incorrectly, I guess. And then my select statement was the same, I think. Well, I select, instead of name, the department name, my select statement was the employee name. And then my group by, I think I was only grouping by department ID. So yeah, I don't think I got it.
Yeah. So like logically, that's what we want. We're like, hey, I want you to group by department ID and I want you to give me the employee name. Unfortunately, if I were to include something like employee name here, I'll just get a big fat error message because it's going to say, I'm doing this set operation. I'm joining all of the employees and all the departments together. So now I have this set of data with rows and columns, right? Then I'm going to group it by department ID so that I'm going to get down to 1 row per department in my new grouped data. In my group data, I don't have an employee name. It doesn't exist anymore. All I have are the department ID, department name, and anything that you do in aggregate function, you can do max, average, whatever. That I can do because I can turn, right, multiple rows of salary, and I can turn it to 1 row by just taking the max of it, or I can turn it to 1 row by taking the average of it. But if I have 5 different employee names, SQL Server says, I don't know what you want me to do with it because you didn't put this, you didn't put a function around this. Now you can get it to run without an error message by saying this. And this is what I was trying to hint at last week, that this will give you the name that is last alphabetically, but not necessarily the name that actually has the highest salary. It will compute this max completely independent of the salary. And so you'll just get whoever's last name begins with a Z. Make sense?
Yeah.
All right. Anybody else want to share some thoughts?
Can't we just use this as a nested query? Like this part is the nested query?
Okay, so what would you nest? Like you're saying right here in my select?
Yeah, so withholding, not including the employee name. So the part that you just, added, max ename, we just take that out, but then include the rest of the query as a nested query, and then we can say something like, because we want the employee that has that, we want the name of the employee with the max salary, right?
Yes.
Can't we say, so for example, we could say, we can have the main query is select the name of the employee.
So I'm sorry, Silly, you need to give me more specific directions. You say either put my cursor like at the beginning and and
Yes,
turn
sir.
this whole thing into a subquery, or somewhere in the middle, put my cursor?
I'd say turn the whole thing into a subquery.
Okay. So this is now a subquery.
And then the main query is we select the employee name from the table with the employee names. And then we could say where salary equals, then we'd need to select the maximum salary from the query, from our nested query.
So one difficulty with doing it this way is that when you do something like a subquery in the where clause, it needs to return only a single value. And right now we're returning multiple rows, one for each department.
I once seen a solution, but I'm not sure that I remember it correctly. So the idea
All right,
is
I'm gonna ask you to hold on a second, Maya,
Okay.
because actually Chris has his hand raised. So I'm
Okay.
gonna let him go, but you can be next.
Yeah, I was thinking, I mean, I still haven't read the book yet. I'm still new, but I'm thinking, wouldn't a filter function work to be able to return all values for each department where you can filter? Would that work?
So when we talk about filtering rows, I'm going to delete this if that's okay, Sule. So generally speaking, that means we're going to add something to the where clause. Okay. So in theory, I could say where the row is the guy with the highest salary, but I don't know exactly how to tell SQL Server to do that, because it's the one calculating which row has the highest salary, and it's not telling me which row that is.
Oh, okay.
See? But I mean, that you guys are all right. You're all pointing to exactly what we want SQL Server to do, but the tricky thing is that if it were the row with the employee name John Smith, we all know how to do it very easily. Like what your where clause right here, Chris, that would work. And Sule's, subquery, might work or whatever. But in this case, we don't know which row it is. And so we kind of either need to do something. So
Well, I think Sule is on the right track. Couldn't we do a subquery in the select where we're taking the max salary? And so we just go select d dot name where, from, oh no, I guess it would be employee dot name from employee where salary e dot salary, or where max e dot salary equals, and then we have the query that we put together, from employee e join. Would that
so
work?
where would you want me to put what you just said? Tell me where to put my cursor.
So everything below max e dot salary is good. So that would be the main query.
And so where are you thinking I'm going to type this?
And then
What you said.
And then it would be below select. you would have,
So like here? Or,
yeah, for now, put it there.
and so you want me to put a subquery here?
Yeah, put a subquery there,
Okay.
and it would just be select, yeah. No, and then it would be e.name, and then it would also be max e.salary.
In a subquery, I can only return one thing.
Oh, okay. So I guess that won't work. Could we do, yeah, just e.name from employee, and then it would be where max salary equals the result from the main query.
So actually, let me give this a new name too. So we can say where e2.salary equals max e.salary. So this is the general gist, I think, of what we want to do. Not 100% sure if we can stick a max in here. But this is, I don't know, this might work. This is pretty close. I don't think we're going to be able to get away with this max in here. That just, sorry, I think I need to sign up to actually run code in this window. So I otherwise I would just run it. It doesn't look kosher to me.
Yeah, I just thought if we could get the max salary from the subquery and the max salary from the main query, and then just take the name from the main query that comes up. But I can't think of a way to actually write it.
Shouldn't we have having with aggregate function?
We can do a having. What having does is it basically applies a where clause after grouping. So it will filter the group. So right now we have what we want. We have one row per group. So I don't know that we want fewer rows than that, but there might be a way we can do this with having. All right, so let me show you guys what I was thinking. Let's see here. I'm not sure actually if the thing that I was thinking. All right, well, so I'm going to show you something that we haven't necessarily explicitly covered in this book. And this is a technique that you will likely find convenient and want to use to solve a lot of these types of interview questions. Okay, I don't know that it's covered in the book. So we talked about subqueries, and we talked about putting it here, where basically it has to return one value, or we talked about putting it in the where clause. Oops. So you might say blah, blah, blah equals some subquery. Okay. And then it can only return one thing. And if you change this to an in, then it can return multiple values, but it still has to return only one column. Okay. There is another way to use subqueries. And when you do this other way, it's actually allowed to return multiple columns. Okay. So what I can do is I can actually say inner join and then put any old select I want here. And then I'm just going to name it for purposes on, and then have some criteria. Okay, so I think I thought of another way, but I might have been mistaken. But the easiest way, the way that I would write this right off the bat, is I would say select what is it? E dot department ID. Wait, yeah. Select E dot department ID, comma, max E dot salary. Actually, let me just take this out for a second and write it separately. So I'm going to select the department ID and the max salary from my employee table, and I'm going to group by department ID. Okay, so this will give me one row for each department. It'll give me two columns, the department ID and the max salary. All right. If this were sitting as a table that I could use to join against, that would be awfully convenient, wouldn't it? So now if I just say, ta-da, this is a table and it's a table named Q, then I can kind of do this. Well, I'm just going to paste it in here. So it's kind of long the way I formatted it. It's kind of ugly. But now basically what I could do is I could say, I only want the employees where the employee department, sorry, I'm going to change this to E2. So where my main query employee department ID equals my subqueries department ID, and my salary equals this guy's salary. So clean this up a little bit here. So I don't need any group by or max or anything in my main query now. Okay, because what's going to happen is I'm returning single rows from these tables, but I'm joining on this subquery, which is going to, this subquery is going to have exactly one row per department. And so when I do that and I join that to employee and department, I'm going to get exactly one row per department in my final answer. Does this make sense?
Yeah.
So I was actually trying to avoid using this particular thing yet, because I thought it might be covered later in the book. But a lot of the sample problems that I looked at, essentially, I found myself using this version of subqueries. Later on, we'll see that you could do this in today's lesson. Sule covered creating tables. So what I could have done was I could have said, you know, create table Q. And then said that it's going to have whatever, a column called, what did I say? Department ID. And a salary. And then I could have said insert into Q this sucker. And then I would have had an actual table Q in the database with one row per department. And then in my join here, instead of it being a subquery, I could literally just say, I temporarily grab this, inner join Q, because Q is a real table now. Okay. And then we'll learn that there's different kinds of tables, and we can do a temporary table. And then there's this thing called a common table expression, a CTE, because this pattern is so common, okay, that if I did this, then what I would have to do is I would have to, when I'm done, if I'm being a nice person, I would have to actually delete my table. Okay, just because, you know, I don't want to leave this extra thing. But then what happens if somebody else is running this same type of query and they call their table Q? Well, that's going to cause problems, because now we're both going to try and create a table Q at the same time, whatever. So there are these things that we'll probably do in the first supplemental session after Thanksgiving, after we're done with the book, really talking about temporary tables, or what they call CTEs, which is a way where you do this, but you're not creating a real permanent table Q that everybody can see, because that will then cause problems, because then you have to find some way to uniquely name all of these intermediate temporary tables that you're trying to work with. And so most database systems do allow, they have a way for you to deal with this. But basically, this is, again, a way that you can sort of piece things out in order to avoid having to have really ugly looking subqueries buried inside of your answers. I find that a lot of the interview questions, if they're not beginner questions, then sometimes it gets ugly if you have 2 or 3 subqueries kind of in there. It's just very hard to figure out a way to format it to make it look pretty. But conceptually, whether you do it this long way or whether you bury it in there as a subquery, it's doing the same work either way. All right, well, I hope that was useful. Any questions?
Yeah, so when we did the inner query, it returned the max salaries, the department IDs, and the names. And then in our main query, we're selecting, I mean, it looks like the main query is, oh, it's displaying the same information, but it's also giving the department name. Is that correct?
And the employee name, I forgot to add that.
Okay.
That was the whole point of this business, was to get the employee name. I'm sorry.
So if let's say we had an interview question asking for the, let's say it was just, they just wanted the name of the employee with the maximum salary, just.
You would
We would
still need
produce-
something like this because remember, our original query had max and it would only give you the number of the max salary, but it wouldn't tell you anything else about that row.
Right. Okay.
So what we're doing here is we're using enough information to uniquely identify that row. We're saying department ID and this max salary is enough information to uniquely identify that row. So now I'm going to take my employee table and I'm going to join on that information that uniquely identifies which row is the row with the max salary.
Gotcha.
And thereby, I've now found a way to get the entire row that had the highest salary. Whereas max only gives me this one number, it doesn't give me the whole row.
So in the main query, where you're showing the department ID, the name of the department, the name of the employee,
Mhm.
and the name of the salary. If you were to just keep the name of the employee and the salary, would you get an error?
No, I could have as many or as few of these as I want. There's no group by in the outer query anymore. So you can do anything you want.
Okay.
And so in addition to the name, if the employee table had 100 columns, I could return all 100 of them because there's no group by here. This is the place where I did the group by in order to identify just enough information to tell me which rows I wanted from the employee table. I want one row per department, and it's going to have the ID and the salary that I need to pick out that one row per department. All right, I will post this in the Slack, in the book club channel as well. But there's a problem I found on Strata Scratch. It says find the average total compensation based on employee titles and gender. And the way it works is there's an employee table that has their base salary, but there can be multiple rows in this bonus table that have a bonus amount. Okay, and so you need to figure out a way to add all the bonuses for each employee to their salary. So that's going to involve some kind of join, right? And then you're going to follow the instructions in terms of whatever they say. Report the average by title or whatever, you know. But the main trick is you got to figure out how to combine the bonus information, which is in one table, with the salary information in another table, and then follow these instructions in terms of find the average blah de blah, and then they try to make it a little bit trickier by saying exclude whatever. They want you to exclude employees who don't get any bonuses. So it's really kind of like they took a simple problem and then they just threw in a few extra curveballs. But I would say when you're solving it, first just say, can I calculate how much every employee made base plus bonus? And then if I can do that, then can I do these averages they're talking about? And then if I can do that, then I maybe try throw in this extra little business. But again, I think it's most important for us to cover the base concepts. So here is the link to that one, and I'll also put it in the Slack.
And is there a foreign key that we use to join?
Yeah. It says, doesn't say. Basically, I'm pretty sure that this worker ref ID is the employee
okay.
ID.
Okay.
Sometimes they're better about explaining the exact way the tables connect.
Might be in the hints, maybe. I don't know.
I don't know. Yeah, I'm still learning Strata Scratch. One, 2, 3, 2, 14, 17, 30. Oh, there they are. 1, 2, 3. Yeah, I think it's just I think that's just this guy here joins to the employee ID. Well, and again,
Okay.
even if it doesn't, that's the concept that we need to master today. So somewhere there has to be a column. So even if I said the wrong column, it doesn't change the fundamental concept of what we're trying to do. Okay. So we're joining employees to bonus, but if you read the directions, you'll see they can get more than one bonus. So there can be more than one row. It is not, there can be 0 rows, there could be 1 row, there could be multiple rows. And so you need to figure out a way to just handle, all of those cases at the same time.
What happens in SQL when you add a number and a null value? Because R will give out an A in such
Yes,
case.
same thing in SQL. Anything that you do with a null, it turns the answer into null. So string concatenate with null, 1 plus null, date with null, anything that you do with a null, then you just get a null. The only possible thing is a function like is null returns true, false, right? But any kind of like arithmetic operators, that kind of things, anything that touches a null will just get turned to null. I believe it should be the same in R and Python, that once you have an NA, if you try to do anything with it, you just get NAs. All right, any other questions? So at the end of next week, we can go over this, and if you have questions, you can also post stuff in Slack, and I'll monitor that throughout the week.
Thanks, everyone.
All right, thanks again, Sule. Thanks, everyone. See you next week.
Thanks,
Bye.
bye.
Thank you.